So to warm up, we've got this bagel shop here, and you can buy bagels in a variety of combinations: 1, 6, 9, and 12. And here's 4 people are saying different things. So they're buying 13 bagels, and the shopkeeper, the person that's run the place, says that'll be $16.25. But Jada, Priya, and Han, they have different ideas. Jada says, I think it should be $13.25. Priya says, I think it should be 13 even. And Han says, nope, $11.25. And I'll let you know, they all got there using good math. So your job with your partner is to figure out how they got their answers. You can use this table off to the side. I personally went and listed the 1, 6, 9, and 12 bagel combinations on that table. So what you need to try to figure out is how did they come up with their answers. They all actually work. Who do you think is actually right, though?
Off of names, though?
Shopkeeper, like the guy that runs the place. Anyway, figure out how they got their answers, please. Let's see if we can read the minds of these 4 individuals. Who can tell me how they think the shopkeeper got $16.25? What did the shopkeeper do, Sean?
So he added $1.25 per bagel.
Yeah, he did $1.25 per bagel times 13 to get to $16.25. All right. How did Jada get to $13.25? How did Jada get to $13.25? Ready?
I think because just for one bagel would be like. Oh wait, never mind.
Okay, 13. Yeah, what do you think?
Like 6 bagel, like 2 6 bagels.
Yeah. So 6 bagler. Just made up a new word. A 6 bagler is $12, right? 2 of them, I mean. 2 6 baglers would be $12 plus $1.25 for that one extra. That would total the $13.25. So I think Jada was like, I'll get a 6er and a 6er and a single. That's $13.25. What did Priya do? How did Priya? Priya got 13 even.
That's $1 a bagel.
$1 a bagel, but where do you get it?
No, I'm stupid. No idea.
You're not. That's fine. Yeah.
She
Sorry.
did 4. She did 4 single bagels.
Yeah.
And then 9 bagels.
So she did a 9er, which is $8, right? A 9 bagler is $8, and then she did 4 individuals at $1.25 each,
Would add up to.
which is the $13. And then Han, I'm on Team Han, man. I want to spend the least money. How did Han get to that $11.25?
I think he just went 1 bagel.
Ivy, what do you do? What do you do, Brennan?
He added $1.25 to $10 because it was one more bagel.
Yeah, he did a 12 bagler and then added a single bagel to it. Now, in context, here's what's probably going on. In context, I'm personally going to probably side with the shopkeeper. You know, this person's dedicated their life to keeping the shop of bagels. So I'm thinking they know what they're doing. And what I'm going to guess the reason for these different packaging and pricing is, imagine you go to this big bagel store, man, the House of Bagel, I don't know what it is. Lots of bagels there. And they have like 12 different types of bagels. Well, if you're like, I need 13 of these and I want one of this, one of this, one of this, one of this, that takes a lot of time and labor for whoever's working there, right? So they're probably $1.25, $1.25, $1.25. I would guess in real life and context, you get by 6 bagels, that's probably like in a package and they're all the same maybe. So guess what? You just grab a package, right? So I would maybe be like, well, if Han bought 12 of all the same and a random other one, yeah, that makes sense. But if this person's got to go back there and pick out 13 individual bagels, maybe that is $1.25 versus prepackaged things. You know what I mean? You guys seen the difference there?
Yeah.
They're all kind of right, though. Maybe the shopkeeper's the next math teacher and lets people try to justify their answers, and if it makes sense, he lets them get it cheaper. And if it doesn't, maybe that's what he does.
Open a bagel.
I want to point out and look at some stuff here. So these different dots on the left, those are the different situations. So see these blue dots? Who would be the blue dots? Which person would be the blue dots, do you think?
I would say Jamaican.
I think the shopkeeper. $1.25, $1.25, $1.25, $1.25. Now, why aren't they connected? Why aren't the dots connected? Why is it discrete? That's the word we use for it. Ivy?
It's not like a proportional.
Well, in this case, it is proportional, but why aren't they connected? Why isn't it continuous?
You can't buy like half a bagel.
Yeah, you can't buy like a part of a bagel, right? It's one bagel, two bagel, three bagel, right? So that's the shopkeeper. Is this a function? Is the shopkeeper a function?
Yes.
Yes. And remember, what makes a function?
Goes through the origin.
No, that doesn't make it a function. Each input has
One output.
one output. I think, which is pretty common, JP, on the test, people would say no, not a function. Linear, there is a linear function or a proportional function, but the two things are like different, right? So to be proportional, it has to go through the origin. This green one, that's the 2 packages of 6, and then one more, I think, or 1 package of 6, then individuals. Also a function. I'm going to try to do the little dots on there. So you notice in everybody individual is a function there. Now here's the real deal. Here's probably the real way to go about it. Individuals are $1.25 until you hit 6. Then a 6 bagel package is how much money? $6 right there. In fact, don't buy 5, right? Because 5 costs more than 6. But then for bagels 7 and 8, how much more for each one of those bagels individually? $1.25. So $1.25 more, $1.25 more. But then there's a special price for a 9er.
Don't buy 8.
There's that 8. Yeah, don't buy 8, buy 9, because it's less money to buy 9. Then a $1.25, $1.25, then a special price for 12. So again, is this a function? The real deal? Yeah, that is a function. Is it linear? No, it's linear-ish, but it's not linear. It'd have to be a perfect line with a constant rate of change.
Is there a definition of linear-ish?
I just made up the word right now. It's like there's like a linear trend, right? If this kept going, there'd be like a trend, but it's not a perfect line. To be linear, it's going to have the same rate of change over and over the whole time. But notice it is discrete. Now, in terms of bagels, what's our independent and our dependent variables? Let's label those real quick. What's our independent and dependent variable?
Bagels.
Well, bagels are what? Number of bagels. Would that be dependent or independent?
That would be
Independent.
Independent.
I said that.
Okay. And what does the number of bagels change? Price. The price depends on the number of bagels. So one thing we could say this is, we could say, like, price is a function of how many bagels. Okay. That's another way we could state it. The price is a function of how many bagels there are. There's 10 bagels, the price is this. If there's 57 bagels, the price is bagels, the price is this, and so on. So that's a lot of review from things that we've already done in our unit that we had, the 8th grade unit on functions. Each group's going to get a day. Group 1, 2, 3, 4, day 1. 5, 6, 7, 8, day 2. 9, 10, 11, 12, day 3. What you're going to do is you're going to graph. You're going to do a little graph of what happens. Whoops. One sec. You're going to do a little graph of what happens here. Some things to keep in mind. So everybody has their own situation, but each day, the dog started 1.5 feet away from the post as the owner left, and each day, after 60 seconds, the dog was always 4 feet from the post each day after 60 seconds. So those are some reference points you'll need. Again, 1, 2, 3, 4 does 1, 5, 6, 7, 8 does 2, 9, 10, 11, 12 does day 3. We're each doing one day. All right? Let's get after it. Let's run through all 3 of these. So, day 1, raise your hand if you had day 1. Brendan was listening that time, my man. Day 1, 1, 2, 3, 4. So everybody over there should. Okay, so day 1, here's what we know. The dog started right here. And we know at 1 minute the dog was right here, right? So those are non-negotiables. For day 1, it said the dog walked around the entire time. So everything could look different on your whole thing as long as, like, the proximity of pull is always changing. And it goes to that point, like walking around. It can be anything, though. It could be kind of straightish lines if you wanted. It just has to be through those points, and it can't be like, it can't be straight like that, like I just did.
Super squiggly lines.
Because it's walking around all the time. So it has to go through these points and has to always be moving. Because if it's moving the whole time, I guess it could be walking in a perfect circle at 5. You could do this, like it's walking around and then go straight here. And if it's walking the whole time, could still be that far away. Or 5, it could go up to 5 and be that far away and just do circles. Anyway, there's options for that one. Okay, for day 2, also has to go through this point and this point. But on day 2, the first minute it walked around, and then then it laid down. So it's like walking, and then if it laid down at a minute, that has to be straight there, right? Because it's not going to go any further closer away from the pole. All right, the last one. Day 3. Started there. We know at 1 minute it has to be at 4. And the dog tried to follow its owner, so it's like, boom, hit the end of the leash. It yeeted it back to here. Okay. And then it started walking around the post in one direction. It kept walking. So it's like turned itself into a doggy tetherball. Okay. And I would kind of do it like that. Like, you know, at tetherball, the last few times around is kind of quick. Maybe the dog kind of did that. I don't know. But either way, has to go through here. Has to peek at 5 feet away because it tried to follow the owner into the store as far away from the pole as it could get. Has to be at 4 feet after a minute, and then it has to end up walking around the post until it's tied up like that. So those are the non-negotiable points. Now the next things I just want to talk about real quick. Who can tell me what the independent and the dependent variables are in this situation? Independent and dependent. Sean, you got me?
Is independent time?
Time's independent, and the dependent is distance, because the distance depends on the time, right? And so another way we could say is distance from the post is a function of the time. That's another way we can say that. All right. Is this a function? Yeah. At any given time, can the dog be 2 distances away from the post at any given time? No, it's only 1, unless it like somehow cloned itself on the spot. And those 2, I don't know about that, but yeah, time travel clone dogs. But in our situation here, it is a function. Does it have to be a line to be a function? No, there is a thing called a linear function, but this is a function still, just not a linear function. Okay, so now you're going to get 2 premises, and you're going to kind of roll through those same things. You're going to tell me independent, dependent. You're going to write it as a sentence and sketch a possible graph. 1, 2, 3, 4, 5, 6. You're the first bullet. 7, 8, 9, 10, 11, 12. You're the second bullet. Okay, and you're going to run through the same thing. So we got a dog, and the dog is barking. And we got a dog, and that dog is total distance. That's different, right? Last time was proximity to pole. This time it's total distance. So the barking one is actually a little bit of a challenge, okay? So independent, we've got time, right? Dependent, we have barks. Now here's the challenge. Are there partial barks? So let's say, I don't know, what'd you guys do for scale? 30 seconds, 10 seconds? Let's do 10, 20, 30, 40, 50, 60. Let's just do that. So the barks could be a different thing for different situations, right? Like, let's say your dog doesn't bark that often. Well, that'd be one thing. Let's say someone comes by on a skateboard and your dog gets triggered and goes nuts. That's lots of barks. But one thing I just want to point out is, whatever your situation is, we're going to have our barks. It needs to be discrete. I would maybe use something like a piecewise function. So 10 to 20 seconds, there's that many. 10, that many, that many, that many, that many. Something like this. Here's why. Or just specific dots at certain time intervals. Are there partial barks? No, so we can't have something like this, because that would show infinite answers. And there's not infinite answers. There's 1 bark, 2 barks, 3 barks, and so on. Another thing is, should this ever dip down again? If it's total barks? No, you can't have negative barks happening. Oh, maybe like it sucks in barks. But no negative barks, okay? So something like this. You need to show that it needs to be discrete or piecewise. I would also be cool something like 0, there's this many. At 10, there's this many. 20, something like this. Could be something like this, okay? That's cool too. We just can't have, it has to be discrete, can't be continuous, okay? Do you guys see why?
Yeah.
Not partial barks, okay? Now, so if we did barks in time like that, time would be independent, barks would be dependent, and you would say that barks are a function of time. So barks is a function of time. Cool? Let's talk about this total distance though. So instead of time as my independent, my distance is going to be independent. Sorry, time is still independent. Instead of barks being dependent, it's going to be distance, total distance, right? So this is different than proximity to pole. So at 0 time, this one has to go through the origin. The dog hasn't gone anywhere, right? But whatever your story is, this one should be continuous. And it could be something like this, although it has to always go up, right? There's not going to be negative distance. And your story could have different things. It's running or it's chilling. Either way, it should go up, up, up. Can't go back, right? And whatever your story is, maybe your dog's just pacing, a constant pace, right? Maybe your dog's just pacing. That's the thing it could be doing. Your story could be different. Either way, distance is a function of time. Distance is dependent on the independent variable time, and it needs to trend up in general. You can't negative bark, man. You don't walk negative distance either, because this is not proximity to pole. This is total walked. Okay, so everybody's graph can look quite a bit different there. So let's make sure we hit it off. Let's make sure we got this. Okay. So we can explain the relationship between two quantities as a function. Each input can only have one output. We can identify independent and dependent variables, and we could put them in a sentence as this is a function of this. And we can make sense of descriptions and graphs and say, what does this say about a situation? We've done it. So with your table partner, as I'm handing out homework, I don't need you to write this down. I just want you to talk through this different example. You're going to practice the independent, dependent in a sentence. And you could just explain what your graph might look like. You don't have to write it down, but make sure you and your partner talk about this while I go and hand out some homework.